In this video, I'll talk about enthalpy of hydration. What is enthalpy of hydration? I'll give you one example. If we dissolve potassium plus ions and fluorine minus ions in water, they will be surrounded by water molecules. The enthalpy of the whole system will decrease. And this enthalpy change is called enthalpy of hydration. And it's always a negative number for ions, always. And I will show you how to calculate the enthalpy of hydration of potassium plus and fluorine minus by using the lattice enthalpy and enthalpy of solution of potassium fluoride solid. So this G means gas phase. And when you see this gas phase, that means this potassium plus is far away from any other ions. There's no attraction or repulsion. Now let me show you the reaction associated with lattice enthalpy over here. So we start from separated K plus and fluorine minus, both in the gas phase. The product is potassium fluoride crystal in the solid phase. The enthalpy change of this process is negative 821 kilojoule per mole. That means if 1 mole K plus reacts with 1 mole fluorine minus to form 1 mole this Kf crystal, the enthalpy decreases by 821 kilojoule. Now I'm going to show you a second reaction that's associated with enthalpy of solution of potassium fluoride. It's very simple. It's just you dissolve 1 mole Kf in water. You will end up with potassium plus surrounded by water molecules and fluorine minus surrounded by water molecules. AQ stands for aqueous solution. And because of the attraction between K plus and water, the attraction between fluorine and water, this enthalpy of K plus AQ and F minus AQ is much lower than separate K plus and fluorine minus ions. However, this enthalpy of solution is positive. Why is that? It's because to form K plus and fluorine minus ions, separated ions, you first need to break this crystal apart into those ions. So this part takes energy. This part releases energy. Overall, delta H is plus 2 kilojoule per mole. Now let's look at the enthalpy of hydration of K plus and fluorine minus. What we can do is we can sum up these two chemical reactions. So all we need to do is we need to add up the left-hand side, 1, 2, 3, 4 items. We add up the 3 items on the right-hand side. All right? And then we notice this Kf in the solid phase and this Kf in the solid phase cancel. So on the left-hand side, we have 1, 2, 3 items here. On the right-hand side, we have 1, 2, only 2 items. The reason I put N here is because I don't know how many water molecules are required to fully solvate this K plus and this F minus. Usually, it takes tens of water molecules to completely solvate K plus and fluorine minus. Overall, the enthalpy change is negative 819. This is because enthalpy is a state function. So we can start from here and we get this. We can start from here and get this. And we can sum up these two reactions. At the same time, we sum up these two numbers. The sum of these two numbers is negative 819. That means the enthalpy of hydration of K plus and the F minus is negative 819 kilojoule per mole. The sign is negative. That means heat is released. Again, the enthalpy change of a process is equal to the amount of heat under constant pressure condition. And we usually do this kind of experiment under constant pressure condition. Now, practice problem. The lattice enthalpy of this salt, very general, it's A plus B minus, is negative 500 kilojoule per mole. And the enthalpy of solution of A plus B minus, this salt, is negative 50 kilojoule per mole. Calculate the enthalpy of hydration of this A plus ion and B minus ion. So again, the enthalpy of hydration of A plus and B minus is the enthalpy change of the process in which we put many water molecules around this A plus and many water molecules around this B minus. How do we do this? Well, we use the same algorithm. So this is the enthalpy of this first reaction here. A plus in the gas phase reacts with B minus in the gas phase to form AB crystal. And over here, this is the lattice enthalpy, negative 500 kilojoule per mole. The second chemical reaction is the dissolution of this AB salt. We put this AB salt in water, and then A plus is solvated, B minus is also solvated. And let's say this is a exothermic reaction. This amount of heat is released, therefore delta H is negative. And then what we can do is we just sum up these two chemical reactions. We get this new reaction, A plus and B minus react with water molecules. The result is this. A plus is surrounded by water molecules. It's solvated by water molecules. Similarly, B minus is also solvated by water molecules. Overall, the enthalpy change is this number plus this number. The result is negative 550. Therefore, we say the enthalpy of hydration of A plus and B minus is negative 550 kilojoule per mole. Now you may ask, can we actually calculate the enthalpy of hydration of A plus only? That's impossible because we have to dissolve A plus and B minus in water together. It's impossible to simply dissolve 1 mole A plus in water without the counter ions.